Let's talk about gravity here. That's going to start this next video off. So jumping right into it. Gravitational force, we've already defined it in class, but we're going to kind of re-go over it and talk about it in more detail. Excuse me. Gravitational force is a force that attracts any two objects with mass. And as a side note, if you want to be a little more precise, you can also include or energy. We're not going to talk about this part in this class, but it is something that kind of lay the groundwork for future physics that you might study. And we commonly consider this for stars or planets, but it also applies to smaller objects. And the reason we don't talk about it for smaller objects is because for smaller objects that force is very small. So it is, we'll just say very small and dwarfed by other forces. So the gravitational force that, say, for example, I have on my little stylus here, that force is so small that any other forces, even the force that it's sitting on my hand right here, like it's not gonna, my body's not gonna pull the pen off of my hand and towards my body. And the equation to solve for or to calculate the gravitational force is equal to big G times m1 times m2 over r squared. This is the universal gravitational constant. Universal gravitational constant. And it's equal to 6.673 times 10 to the negative 11th. Let me double check my notes. Yep. I don't always remember the exact power. Newtons, meters squared per kilogram squared. You don't have to have this memorized. I'm just pointing that out. This is the mass of both objects. So m1 is obviously one object, m2 is the other. And this is the distance between objects. More specifically, between the center of mass. So for example, with me being pulled towards the Earth, it'll be the distance between the center of my body and the center of the Earth. So it's, effectively the radius of the Earth. And then m1 would be my mass, m2 would be the Earth's mass, g is a constant. We could multiply that together and we'd get the gravitational force that my body is being pulled on by the Earth. Conversely, we also get the force that my body is pulling up on the Earth. So acceleration due to gravity. We can use those known values. So if I'm close to the Earth and I'm using the radius of the Earth, what we'll end up finding is that Fg equals 9.81 meters per second squared times the mass of, whatever the other object is. So if I plug in G, I plug in ME, I plug in RE, and you'll have those in a second here if you want to test it for yourself. You get this, which if you recognize is also equal to mg, where we said g was the acceleration due to gravity. So this means more generally we can rewrite this equation as g is equal to big G times the mass of the planet or the mass of whatever object you're looking at divided by the radius of that planet or radius of that object. And so this ends up being useful for calculating G, for calculating the acceleration due to gravity if you're farther from Earth or if you're on a different planet or stuff like that.